Whenever you're ready.
Louis, select down.
Hello.
In a professional way.
So I'm going to be demonstrating my VR circuit builder I made for my coursework. So the equipment I'm using for this is an Oculus Quest 1. This is the headset. Also has 2 controllers that can track where your hands are. So I've uploaded the project onto this headset, and now I'm going to show you what it's like. You'll be able to see what I'm doing on the whiteboard up there. Alright, so I'm just going to get this all set up. Okay. So you can see I've downloaded it onto the headset there. I'm going to open it now. So yeah, I used Unity to make this program. So this is my coursework. Basically what you've got here is you have a help window here, which you can use to find information about how to use the simulation. You've got a workspace window here that displays information about which component you're currently selecting, and then shows you its properties and allows you to change those. And you've got this workspace here which you can actually build circuits on, and you have a bin to throw away components you're no longer using. So these menus can be scrolled using the scroll bar, and they can also be scrolled using your hands, and that has a little bit of like drag, so it can keep going after you let go of it. And this one has that as well. So first of all, to start, I'm going to create some components. So the way I do that is I use this controller or this controller and press a button, and it brings up this menu which now follows the controller and rotates with it as well. And I can use these pointers on the controllers to point at that button and press the trigger to select it. So I'm going to make a power cell, and it appears there. So I can grab this and move it around, and it's affected by gravity and physics. And when I hold it, you can see on the workspace window, information about it appears. You've got its name, a description of it, you've got its potential difference here, and its current and resistance. And the potential difference can be changed using this input box. For other components, this will be resistance that you can change, and potential difference down here that you can't change. So I'm going to construct a circuit now. I'll put that there. I'll make a resistor and a filament lamp and set those up. And now to create a wire, what I do is I use the same controller, I use the other button, I press the button once to create a start point, and press the button again to create an end point, and it draws a wire between the two. And I can move the start and end point. If I grab the white sphere, I can move that around, and it draws the wire between them when I let go. If I grab the red sphere, I can move the entire wire at once. So I'm going to connect this now. So it snaps onto the little connectors when you let go of it. And I can also create them directly onto the connectors as well, like that. So then when it's connected, you can see the filament lamp lights up to show that the circuit's complete. And if you hold this, I'll just connect it again, you can see here it's got its resistance, its current of 1 amp, now it's in a functioning circuit, and its potential difference of 2 volts. And this has a resistance of 4, and the power cell has a potential difference of 6, which means that 1 amp current is correct. So I'm going to now demonstrate some of the other components I've created and how they work. Also, you can detach the circuit just by grabbing one of the little nodes and putting it out, and there we go, that's now detached. So I will now add a buzzer, show you what that's like. And that now sets up like that. And I can also add a switch to control. So if I'll show you the bin now, you can just throw things away and they disappear. And I'll get the switch. The switch can actually be flipped on and off using the trigger. And if you connect that in, one moment. Oh, it's because this is not connected, that would be it. And now if I grab the switch and flip it while it's connected, it turns off and turns back on. So that's all of the components I created for the simulation. And I'll now demonstrate how you can change the value of one of the components. So if I'll just attach this for now, and I'll grab this, let's grab the filament lamp. So I'll hold the filament lamp. Now the way this works, you can see that I added more components of different resistance, so its potential difference in current changed. They display at the time of when you grabbed it as to what the values were at that point. So if I want to change this to, let's say, 3 ohm instead, or let's go with 20. So we'll go 20. So I press a trigger on this box, and it brings up a virtual keyboard that I can use. So if I switch to numbers, and I'll add a 0 on the end, and close it, and now if I let go, and grab it again, you can see it has changed to 20. So I'll now connect the circuit up. And now you can see that the current is a lot lower thanks to the new resistance. So I think that's about everything I wanted to show. So thank you for watching. So does anyone have any questions?
Any question, guys? Yeah, that's brilliant. I would say that's a really I think a nice project. Very good, very innovative, very thoughtful project, and very detailed. That's well done, Alessandro, for that.
Thank you.
Any question, guys? If you guys
Do you have any plans to take it further?
I do actually. I have. There are some components that I haven't fully fleshed out, but I have got like physical models for that I'll hopefully work on in the future, and I intend to also implement support for parallel circuits as well, which I didn't do right now because I was under a time constraint and it was quite difficult to get the whole thing to work, as you can probably imagine. Any other questions? Okay then, thank you so much for listening and watching, guys, and thank you for listening as well.
Thank you.